students, today I am going to continue the 7th standard science chapter, that is transfer of heat. So we have started this chapter and we have discussed about how the heat transfers from one object to another. Okay, how many types is there in transfer of heat? Can you recall? Yes, okay, there are 3 types in transfer of heat. Okay, which are the 3 types? They are, first one is conduction, second one is convection, and the third one is radiation. So, what do you mean by conduction? Conduction means the transfer of heat from one object to another, and means if I take the example, okay, transferring the hot milk from one glass to the beaker containing another glass cold water. Okay, when you transfer the hot milk to the beaker containing cold water, what happens? The temperature of the both beaker will becomes the same. The temperature will comes down till they both attain the same temperature. So that is nothing but transfer of heat. Okay, for transferring the heat from one object to another, they require the medium. So what is the medium there? The medium is air. Through the air, when you transfer the hot milk to another bowl beaker containing cold milk, because of the presence of air acts as a medium. There is temperature will come down. There is changes we can observe in the temperature of both beakers. And here, okay, here there is no movement of the molecules. Okay, when the transfer of heat takes place, there is no movement of the molecules. Okay, if you take one iron rod and if you heat, okay, when if you take the iron rod and if you heat, what happens? If you heat this end, what happens? After some time you can observe that when you touch, you can feel the temperature of this end increased, and there is no movement of molecules of this iron rod. There is only transfer of temperature. How? Transfer of heat. How? Because of the vibration of the molecules present in that. Okay, because of the through the vibration of the molecules, the heat is transferred from one end to another. And okay, the materials which conduct heat, that we call it as conductors, good conductors. And the materials which do not conduct the heat, we call it as insulators. Okay, we can classify the materials into 2 types. Some are conductors, some do not conduct heat through them. They are insulators. So the application of these both conductors and insulator is very important in our daily life. We use so many materials which are of good conductors and which are of bad conductors. Then we have discussed about the convection of heat, how the convection takes place. So what do you mean by convection? Convection means it is also way of transferring the heat from one object to another. What happens when there is convection? Okay, we can observe the movement of molecules. If you take one beaker containing water, in water and in air, there is no conduction process takes place. Conduction process is very slow. They always, most of the time, they follows the convection. The transfer of heat occurs in water and liquid and gas through convection process. So what do you mean by convection process? What happens? Okay, when you supply the heat energy to the beaker containing water, water layers will be separated, okay, among themselves, and when the lower layer gets the heat energy, it will be heated up and it will expand. When we supply the heat to the liquid or gas materials, what happens, they will expand, they will raise in their level. So what happens here also, when you supply the heat energy to the beaker containing water, the molecules which are at the lower level get heated up and it will expand and it will raise up, it will come up, and simultaneously this cool water molecules will come down. They will occupy the empty spaces which are already occupied by these heat molecules. So there is continuous, and the transfer of heat occurs. Okay, the transfer of heat occurs. The whole water will be heated until the whole beaker, all the molecules are continuously moved. Okay, all the convection occurs until all the molecules of our the convection process takes place until all the molecules of water heated up. Okay, till all the particles of water present in the beaker heated up, it will be the convection process takes place. That continuous movement we can observe. And I will explain you about the convection in brief through this video.
Take a deep breath. Get ready for one of the most hypnotic things you'll ever see in a science class. Have you heard that heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. Understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this for yourself, click on this link for all the directions you'll need. Thanks for watching.
Okay, this convection process. In the convection process, what happens? Okay, the continuous movement of water molecules, when we supply the heat molecules will expand and raise up, and the cool molecules of water will come down and they will settle down at the lower level. That process. That movement we call it as convection current. Okay, we can see this convection current. Example for this application of this convection current in our daily life. Now let us discuss about the convection current in our daily life. Convection current is nothing but it is a process of movement of molecules. Movement of molecules of liquid substance or the gaseous substance. Okay, when we supply the heat, that process is known as convection current. That movement we call it as convection current, and we can give so many examples for the convection current in our daily life. The first one is the land breeze and sea breeze. I will show a small video about this land breeze and sea breeze. Then I will summarize this concept of land breeze and sea breeze.
It's a sunny day at the beach. As the sun rises, the land warms up faster than the water does. This causes the air above the land to also warm up. Warm air, being less dense, expands and rises, leaving an area of low pressure. Meanwhile, the air over the ocean is cooler. Cooler, denser air sinks over the water, creating an area of high pressure. The differences in pressure and air temperature create a convection current. Warm air over the land is replaced by cool ocean air. This air is warmed by the land and rises, and the cycle continues. Winds that blow from the sea to the land are called sea breezes. At night, the convection current reverses. After the sun has set, the land cools more quickly than the water. Therefore, the air above the land also cools down. Cool air, being more dense, presses down over the land, creating an area of high pressure. Meanwhile, because water cools down slowly, the air over the ocean is still warm. Warm air, being less dense, expands and rises, leaving an area of low pressure over the water. At night, cool air over land moves towards lower pressure over the ocean. This air is warmed by the water and rises, and the cycle continues. Winds that blow from the land to the sea are called land breezes.
So what do you understood from this video? So what happens during the daytime? Okay, the land gets heated up very quickly compared to the water in the sea. So land gets heated up very quickly as compared to the sea level, and above the land, the air above the land will gets heated up and it will expand and it will rise and it will become lighter. So it starts moving from land to sea. Meanwhile, the air in the sea level will be cooler. So that cool air starts it will move towards the land side, and it occupies the empty spaces which was already occupied by the warm air in the land. So during the daytime, what happens? The cool air starts blowing from sea to land. So that flow is known as sea breeze. What do you mean by sea breeze? The flow of air from the blow of air from sea to land is known as sea breeze. After sunset, what happens? The land becomes cooler very quickly, and the sea water remains little warm, because that sea level air, the air in the sea level was already occupied by the wind blown by the land. So the sea level water remains warm compared to the land. The land becomes very cooler compared to the sea water. So what happens? In the sea level, the air particles, the air remains warm and it gets heated, it becomes lighter, and it expands and it will rise up, and it starts moving towards the land, and the cool air from the land move towards the sea level. The wind blow from the land to sea during the night time. The flow of air from land to sea at the night is known as land breeze. During the night time, land breeze. So what do you mean by land breeze? The flow of air from land to sea at the night time is known as land breeze. Okay, now let us discuss about the applications of convection current. So the first application is chimney. So in case of chimneys, what happens? Okay, chimneys are you might have observed these chimneys in the factory or in the houses and all. So the smoke and the gas will be removed through these chimneys in the factories, in the houses, you might have observed. So what happens? Okay, when you heat any substance, okay, when you heat any substance, what happens? It produces the smoke or the gas, right? So in the factories they will produce large amount of smoke and the gases. So what happened? When you connect this, okay, heating material, when you connect this material to this chimney, what happened? The smoke and the gas particles will rise up because of the heat. You are supplying the heat, right? So the heat will because of the heat, this smoke and the gas particles will rise up, and they will they will go out through this hole, and simultaneously what happens? This part will be occupied by the cooler air, and this is how, because of the expansion of the gas molecules, because of the expansion of the heat gas particles, heat smoke particles, the unwanted smoke gas particles will be removed through these chimneys. This is one application of this convection current. Okay, in the RCC houses, in the flats, you might have seen these ventilators. So what do you mean by these ventilators? Ventilators are nothing but okay, they are the small openings at the rooftop level. They will keep one tall window or rooftop level, they will keep one small opening. So what happens? RCC houses, flats will be closed, right? Throughout it will be closed. So what happens? Once air enters your room, it gets heated up, so it has to be removed. So it will be closed, right? RCC houses. That is why when we keep this small opening, what happens? The hot air will raise up, they will expand, and they will come out, they will exit through this holes, small opening, that is through ventilators. So this is one application of this convection current, and that area, that room will be occupied by the cool air through the windows and doors. Got it? This is how the convection current takes place in the room. Okay, in the kitchens and all, you might have observed, they will keep one exhaust to fan. Okay, small fan they will keep in the halls, in the kitchen and all, in the room and all. So the room will be closed. So in order to remove this hot air from the room, they will keep this exhaust fan. So the hot air will be removed through the room by this fan. Okay, these are the applications of this convection current in our daily life, and these are the applications: chimneys, then ceiling fan, this ventilators are the applications of this convection current. Okay, the next concept, the next way of transferring the heat from one object to another is radiation of heat. Okay, radiation. What do you mean by radiation? The transfer of heat in the form of waves from one body to another through vacuum or medium is called radiation. What do you mean by radiation? It is a way of transferring the heat from one body to another in the form of wave. This is important. Here what happens? We transfer the heat in the form of waves, and here we the medium, it could be vacuum or it could be anything. Okay, it requires medium, or it without the medium, in the vacuum also we can transfer the heat through this process. Got it? So for the convection of heat, and for the conduction of heat, the medium is must, but here medium is not required. Without the medium also we can transfer the heat from one body to another. Okay, in order to understand the concept of radiation better, you just hold the thermometer near the fire or near the candle. What reading it shows? Will the temperature increase or decrease? Yes, when we hold the thermometer near the hot material or near the fire or near the candle, there is increase in temperature. The reason is there is increase in temperature. The heat is transmitted from the fire or the candle to the thermometer. So without the contact also, how this heat is transferred? The heat is transferred through radiation. Or when you hold your hand near the fire, you feel the warm. The reason is the heat is transmitted through radiation. Okay, in this activity we have observed that there is rise in temperature on the thermometer, and how the heat is transferred from the candle to the thermometer. Is it transferred through conduction process? No, that heat is not transferred through conduction process. The reason is there is no connection, there is no contact between the thermometer and the bulb. So there is, the conduction process did not occur in that process. Does it any convection of heat takes place? No, through convection the heat is not transferred, because there is no level in because there is no rise in level of heat. There is no rise in level of heat. The heat is not raised in this case. So how the heat is transferred from this candle to the bulb? The heat is transferred from candle to bulb by the process called radiation. Okay, through the radiation process the heat is transferred from the candle to the bulb. In this case what happened? There is the heat is transferred from the candle to the thermometer through radiation. What do you mean by radiation? Radiation is nothing but the heat can be transferred. Sometimes it requires a medium, and without the medium also through vacuum also it transfers. So here there is no connection. The medium is not there. Without the medium also the heat is transferred. The reason is because of radiation. So through the radiation the waves of heat energy, the waves of heat energy transfers in a straight line and in all direction. The radiation of heat travels in all the direction. It does not travels only in one direction. It travels in all the directions, so it gets heated up. This is what happens in the case of we get the light energy from the sun. We get the heat energy from the sun. Okay, what happens between the earth and the sun? There is no any medium to transfer the heat from there to here. Without the medium, that is through vacuum, the heat energy is traveled from the sun to the earth. So that is how we get the heat energy, light energy. Through the radiation we get the light and heat energy from the sun. Okay, we know the object appears in any one of the states of matter, that is it could be solid, liquid or gas. Okay, through all these medium, through all these matters radiate heat. All these matters, all these objects which are in solids form, liquid form and gas form radiate heat. They radiate the heat, and the amount of heat radiated through the object depends on The heat radiated by the object depends on the temperature of the object, the color of the object, the nature of the object. Okay, temperature means how much it have the heat energy, how much it was heat, how much it was hot. If it is very hot, it radiates large amount of energy. If it is little warm, it radiates little less amount of energy. That is what. Then color of the object. If the color of the object is light, it radiates little light. If it is dark color, if it is in dark color, it radiates more. Then nature of the surface. The nature of the surface, whether it is shiny or dull. Okay, whether it is shiny or dull surface. The shiny surface radiates more heat energy, whereas the dull surface radiates less energy. That is what. So, the nature of the object radiates depends on temperature, color, nature of the surface. Then the next concept, the amount of radiant heat received by the object depends on distance from the object. Okay, the amount of heat received by the object depends on how it is closer to that object. If it is very closer to the object, then it gets more heated. If it is far away from the object, it gets less heat energy. That is what. So, the amount of radiant heat received by the object depends on the distance from the object. How much it is closer, how much it is nearer to that object. Got it? So that is what happens in our solar system also. The planets which are closer to the sun, they are little warmer. Their environment is warmer. They are little hot compared to the other planets which are away from the sun. Got it? The planets such as Mercury, Venus, then Mercury, Venus, Earth, Mars, they are little closer. They are very closer to the sun. So their surface, their environment is hot compared to the other planets. Got it? Because they get more heat energy. That is what. Now let's conduct an activity to study the radiation from different surfaces. How the radiation depends on the color of the object.
Black color objects absorb and lose more radiant heat than a white object. Let us learn through an experiment. Take two metal containers, A and B. Paint container A with black color and container B with white. Fill both the containers with equal amount of water. To measure the temperature, fix two thermometers in the containers. Note the thermometer reading. Place the two containers in the sun for about 15 to 20 minutes. Again, note the thermometer readings. You will find that the temperature of water placed in the black container rises more than that of the water in container white. This happens because black object absorbs more radiant heat than a white object. Now place both the containers A and B in the shade. You will observe that the temperature of water in black color container cools down faster. Therefore, we conclude that black-colored objects absorbs and radiates heat more as compared to the white object in the same time period.
Let's conduct another activity to study absorption of sunlight by different colored surfaces.
The heat is dangerous and it affects everyone differently. But if you're outside wearing a dark colored shirt, you're going to get hotter faster. So for this week's lesson, we're learning how colors absorb the heat, but we are having a little fun with it and using crayons since the kids are headed back to school. I glued different colored crayons on this board and I'm going to place it in direct sunlight. According to Crayola, crayons begin to soften at 105 degrees Fahrenheit and will melt between 120 and 147. The real science happens when the sun's rays beat down on the crayons. The crayon colors either absorb or reflect the light from the sun. Within an hour, the crayons begin to soften, and around 2.5 hours later, the darkest colors begin to drip. Here's what it looks like after 4 hours. The darkest colors melted, while the lighter colors aren't even soft. Now, let's get into the science of it. This experiment has a lot to do with physics. Different colors have different wavelengths, and each wavelength absorbs or reflects light differently. A black-colored crayon will absorb all of the wavelengths and convert it into heat. The result is a crayon that starts to warm, or in our case, it actually melts. Now, a white-colored crayon reflects all of these wavelengths and it doesn't convert into heat. The temperature really doesn't change much. Now, any of the colored crayons between white or black will either reflect or absorb the light differently. That also means that the heat is converted differently. That's why there's the common saying to wear light-colored clothes in the summertime. That's it for this week's lesson, learning about science where you live. I'm 5 News meteorologist Sabrina.
Okay, now let us discuss about the applications of radiation. What are the applications? The first one is during the summer season, which type of clothes we prefer to wear? Yes, exactly. We prefer cotton clothes to wear, or we prefer the light colored clothes because they absorb less heat energy. That is what. The light color materials absorb less heat energy and they do not trap the heat energy into and they do not trap more heat energy. That is what. So during the summer season, that keeps us little cooler compared to the other type of materials. So we prefer cotton clothes to wear, and cotton clothes or the light color clothes because they do not trap a large amount of heat energy from the sun. That is what. They always keeps us cooler. The second one is during the winter season. Which type of clothes we prefer? Yes, we prefer the woolen clothes. As we studied in the last concept, animal fiber, woolen clothes traps more heat energy and they keeps us little warmer during the winter season. That is why we prefer the dark color clothes and the woolen clothes during the winter season because they traps large amount of heat energy. That is what. The next example is electric room heater. If you observe this electric room heater, behind that they provide one reflector. So the radiant heat will reflect towards front when it gets the radiation. So in the electric room heater, you can see at the behind there is one reflector. So it reflects the radiant heat towards the front. So these are the applications.
Vacuum flask or thermos flask. Thermos flask is used to keep things warm and cold. It consists of a double-walled glass flask having vacuum between the walls, kept inside a metallic case with cork supporters. The outer and inner surfaces of the glass flask are highly silvered. The mouth of the flask is fitted with airtight cork. The vacuum between the two walls of the flask prevent heat transfer by conduction or convection. The silver coating of the walls of the vessel reflects back heat radiations. Thus, heat by radiation can neither enter inside nor go out of the flask. The airtight cork, which is bad conductor of heat, prevents any loss of heat by conduction or convection. Some heat may be transferred by conduction through thin glass walls at the neck and the poorly conducting cork.
Now let's discuss about the difference between conduction, convection and radiation. The first difference is conduction is the direct transfer of heat energy from one substance to another. Okay, there is direct transfer of heat takes place during the conduction process. And in case of convection, okay, convection process takes place in fluid. Convection process takes place in fluid. Which are the fluid? Gas or liquids. So there is what inside the liquid or in the gas molecules. Among the gas molecules, the convection process takes place. And this mainly conduction process takes place in solid material, whereas convection process takes place in gas or liquid molecules. And the transfer of heat takes place through the radiation process in between the empty spaces. Okay, if there is nothing also between the two objects, the transfer of heat energy takes place. The process is radiation. Okay, in radiation there is transfer of heat through the vacuum space, empty space. This conduction process takes place by the direct contact between the two objects. There should be contact between the two objects. And the convection process takes place between the molecules of the substance. Okay, and there is movement of the molecules we can observe. We can observe the movement of the particles during the convection process. And radiation, and the energy is transferred by the electromagnetic radiation. Here the heat is transferred by the electromagnetic radiation. The second difference is conduction process is very slow because the heat travels in one direction. Okay, by the vibration of the molecules the heat travels. And convection by the movement of the molecules the heat transfers, that is also very slow. And in case of radiation, what happens, the energy is transferred by the electromagnetic radiation. So, and the heat energy travels in all the directions. So the radiation process is fast compared to conduction and convection. The third difference is, by the conduction process the heat transfers in straight line in one direction. In case of convection, the transfer of heat takes place upwards and downward direction. The transfer of heat takes place upward and downward direction. Okay, and radiation process takes place in all the direction. The heat is transfers in all the direction. Okay, in your textbook they have given one mistake. Conduction process takes place in one direction only, and convection process heat is transferred upward and direction. That is correct. The radiation process takes place in all the direction. They have written transferred in straight line. That is a mistake. Make that correction. Okay, dear students, in this chapter we have discussed about the types of transfer of heat from one object to another. We have studied about three types, which are they? Conduction of heat, convection of heat, and the last one is radiation of heat. And we have come to know the applications of this transfer of heat. What are the applications we have in our daily life, and how the heat is transferred from one object to another. I will give an activity. Okay, we use so many materials, and uh, we transfer the heat energy from one object to another, and we have so many applicants of this transfer of heat energy. So just list out, just go around your home and find out the application of this transfer of energy. What are the applicants we use in our daily life, and how the transfer of heat takes place in that object, that you have to find out. Thank you, students.